Hello, so this is factoring trinomials and simplifying exponents. We have two learning targets today. We're going to factor trinomials where a is equal to 1, and then we're going to simplify expressions with positive exponents. All right, so if a trinomial is in the form of x squared plus bx plus c form, and a there is equal to 1, then what we want to think is what two numbers multiply to equal c and add to equal b. So we're going to be, when a there is equal to 1, you're always going to factor it like this. Because x times x there is x squared, because your first term there is always going to be an x squared. Then you're going to think what multiplies to give you c. And you're going to think what adds to give you b. So both of those conditions have to exist. Whatever those two numbers are, then you're going to plug them in here. So it's going to be like x plus something and x minus something, or x plus something and x plus something, or x minus something and x minus something. So we're going to talk through all that. So let's come down here and let's look at an example here. So this, again, it's in this form of x squared plus bx plus c, but your a there is 1. So it's really a 1x squared. So when you factor this, it's always going to go x and x. So you want to think what multiplies to give you 10. So let's look at that. Multiplies to give you 10. And adds to give you 7. So 10 plus 1 there is 11. And 5 plus 2 there is 7. So it has to be the 5 and the 2. Again, you have to think what multiplies to give you 10 and adds to give you 7. So what multiplies to give you c and adds to give you b. So there we have it. It's a positive 10, it's a positive 7, so they both have to be positive. So a couple more examples here. So let's go ahead and let's put our x's in there. What multiplies to give you x squared to be x and x. Then you want to think what multiplies to give you a negative 15. Before we deal with the negative, let's just walk through the numbers. 15 and 1, and then 5 and 3. Since the middle number here is negative, and you have to have a negative 15 to get a negative 15 in multiplication, you have to have one of each. And since the middle number there is negative, the larger pair that you choose, the larger number in the pair, that one has to be whatever the b term there is, the sign of the b term. So the sign of the b term there is negative, so the larger number in 15 and 1 would have to be a negative 15. The sign of 5 and 3 there would have to be, 5 would have to be the negative because it's the larger number. And we need one of each. So negative 15 plus 1 is a negative 14. That's not the middle term. Negative 5 plus 3 there gives me a negative 2, so that works. And there it is factored. All right, go ahead and try another set. Put your x's in there. Let's think this time, how are we going to get negative 42? Well, to get negative 42 there, we're going to have to try different ones here. So looking at that, we've got 42 and 1. So I'm going to think 2, that's 21 there. I'm going to try 3. 3 times 14 is 42. And then next one there would be 6 and 7. All right, so again with this pair, since we're supposed to multiply to give us a negative number there, so you need to have one of each signs. The middle number here is a 1, and it's a positive 1, so the larger number has to be the positive value in the pairs. So now which one of those pairs adds to give you a positive 1 there? That would be a 7 and a negative 6. So they multiply to give you negative 42 and add to give you 1. All right, we have one more set here. So let's look at this one here, set her up. All right, so this one here, what multiplies to give us a positive number, 24. But this time it has to add to give you a negative. So whenever you've got a positive there for your C term there, they both have to have the same signs. So, but if the middle term there is negative, then you know they both have to be negative because the C term there is positive. So since 24 is positive, it has to be a positive and a positive, or it has to be a negative and a negative. But two positives can never add to give you a negative, so they both have to be negative numbers when we list them out. So let's just think about the numbers that give us 24 here first, and then we'll work through the signs. 24 and 1, 12 and 2, 3 and 8, 4 and 6. So they both have to be negative because what multiplies give you 24 and adds to give you a negative 11. That would have to be a negative and a negative. All right, so which one of those pairs adds to give you a negative 11? Oh yeah, a minus 8 and a minus 3. So now I have some for you to work through right now. You're going to work through these next few of them. It's 2 through 12 evens, and they're all listed here. So if you want, go ahead and pause the video and work through those, and then come back and I'll have work through those for you. All right, so let me show you what you should have gotten here. So you have to think x and x. What multiplies to give me 6 there and adds to give me 5. So when you came up with your numbers there, for 6, you probably came up with 6 and 1, and 3 and 2. The 2 that add there to give you 5 would be 3 and 2. All right, number 4 there, what multiplies to give me negative 56 and adds to give me a positive 10. Since it's a negative 56, we know one of the signs has to be negative and one has to be positive. We also know that the middle term there is a 10 and it's a positive 10. So we have to think about that the higher number in the pair there would have to be the positive values. So let me start to list them out here. So I'm stopping there because right away now I start to see, oh yeah, negative 4 and 14 are going to be my numbers. So on to the next one here. What multiplies to give me 3? Just 3 and 1. So, and also 3 and 1 there will add to give me the middle term of 4. I'm going to put my x's in there. What multiplies to give me 4 and adds to give me a 4? So we have 4 and 1 or 2 and 2. And 2 plus 2 there is the only way when you add, you're going to get the middle term there of 4. Because 2 plus 2 there is 4. Number 10 here, what multiplies to give me 12? So 12 and 1, 6 and 2, 4 and 3. So what adds to give me 7 there is going to be 4 and 3. So on to 80. What multiplies to give us 80? We can start to list them out there. And again, what multiplies to give me a positive 80, but adds to give me a negative. So to get a positive 80, either has to be plus and a plus, or it has to be a minus and a minus. Well, in this case, it has to be a minus and a minus because it's the only way you're going to add to give you a middle term there of a negative in the middle. So I can start to list them out here. And now I see it now, so I can stop. I've got minus 20 and a minus 4. So now on to our second learning targets there. Rules for simplified monomials. Product of powers, we've got a to the m is times a to the n there. What you end up doing there with the powers is you end up adding those together. As long as the two bases are the same and they are the same bases. You've got a to the m and a to the n, so they have the same base, so you can simply add the powers there together. So the example here, you got 5 to the third times 5 to the fourth there. You go ahead and you can add them together. And then you'd actually find what 5 to the 7th there is and write that out. And then we have another rule, it's called power of a power. That's a to the m to the nth power there. And what you do there is you multiply the two powers there together. You do m times n. So in the next one there, you've got 3 to the fourth to the second power there. You just take 3 to the 4 times 2 power. When you have a power to a power, you multiply it together, and you get 3 to the 8th. And then you could actually find 3 to the 8th. So let's go through some examples using those. So this one here, you got two separate terms here, and so to combine those, we're going to have to add the powers there. So we get x to the 2 plus 3 power there, which gives us x to the 5th. All right, so this one here, you've got 2x to the third times 5x times 3x to the second there. Nothing is a power to a power in there. There's no powers outside the parentheses there. So what we can do here is we can simplify the regular numbers there, the coefficients there. So 2 times 5 times 3 there is 30. So we just multiplied our regular numbers there together. And then we have our terms here with the powers. And don't forget, if you've got x there and there's not a power listed there, it's x to the first. So now we're going to add all those together. We're going to say x to the 3 plus 1 plus 2, which ends up there giving us 30x to the 6th. All right, coming down here to letter C here, we've got 3 to the first. Since it doesn't have a power in there, I'm going to put it in there because I see it's a power to a power there. So everything in the parentheses in there, that 3 to the first and the x to the third, have to be taken to the power of 2. So if I do that, I end up here getting 3 to the first times 2 and x to the third times 2. So that gives me 3 to the second and x to the 6th. And 3 to the second there is 9, x to the 6th. And another way of thinking that is because you've got 3x to the third in there, it's like 3x to the third being multiplied there twice, because that's what this power there says. So 3 times 3 there is 9. X to the third plus x to the third there, or x to the third times x to the third, you add the powers there together and you get x to the 6th. So you get the same answer, just a different way of thinking through that. So again, we have a power to a power. So what do you do when you have a power to a power? You just multiply those together. So we get x to 36. All right, so down here, letter E there, notice we've got some fractions and some just plain whole numbers there. I'm going to take those whole numbers there and put them over 1. It just makes it easier when we're knowing when to multiply the numerators and denominators. It doesn't change the value to put a 1 underneath those. So let's go ahead and figure these out as we go here. So 2/3 to the second, that means 2 to the second and 3 to the second. And then we have 3 to the second over 1. And then we have 1 to the second over 2 to the second. And then we just have a 9 over 1. All right, so now we can look at this one here. We could cross them out as we go here. Remember, you can cross them out either up and down or diagonally if they have those in common. So I'm looking here and I'm saying, oh, 3 to the second and 3 to the second are the same. I've got 2 to the second and 2 to the second. So now I can simply multiply my numerators and multiply my denominators there. So looking here at the top, 1 times 1 is 1, 1 to the second is 1, so that's times 1, times 9 is 9. The denominator down there, 1 times 1 times 1 times 1 is simply 1, which gives us 9. Now here we've got 1/6 times 1/12 times 1/3. We don't have any powers in here, so simply multiply your numerators and multiply your denominators. So 1 times 1 times 1 is 1. 6 times 2 is 12 times 3 there is 36. So we get 1 over 36. All right, so looking at this letter G here, I have to take, notice I have this power up there, so everything's a power to a power there. So I have to take everything in the parentheses to that power. So if it doesn't have a power in there, put them to the first powers. So 3 to the first to the third. 3 to the first to the third there is 1 times 3, which is 3, so I get 3 to the third. X to the first to the third power, power to power, you multiply, so you get x to the third. Y to the second to the third, that's 2 times 3, which is 6. The next one there doesn't have a power to a power, so I'm just going to write 2 times x to the third times y. So now I'm just going to simplify everything. That 3 to the third is 3 times 3 times 3, or you can do that 3 caret key 3 on your calculator, or 3 y the x 3 on your calculator to get your answer there. So that would give us 27. So let's combine our like terms there. 27 times 2 is 54. X to the third times x to the third. You have to add your powers. So 3 plus 3, there's 6. And then we've got y to 6 times y to the first. You have to add your powers there, and that gives us y to the seventh. So there we have it. All right, letter H. Everything in there is to the second power. So let's take everything in there to the second power. So 1 to the second power, 3 to the second power. X to the fifth to the second power is just x to the 10th. Well, 1 to the second there is 1. 3 to the second there is 9. So 1/9 x to the 10th. You could also have taken this x to the 10th and put it over 1 if you wanted to, and then you could have said x to the 10th over 9. So either way works. So I have 2 of those for you to figure out, and so if you want to pause the video and try those out, and then I'll go through those for you. All right, so let's go through these. We've got a power to a power here, so let's take everything in here to the second power in the first one here. So 2 to the second, there's 4. X to the third to the second, 3 times 2, there's 6. So you get x to 6. Y to the fifth to the second power there is y to the 10th. The second set of parentheses doesn't have a power to a power, so I'm just going to write it down as is. Now I'm simply going to combine my like terms there. I've got 4 and 3 there. 4 times 3 there is 12. I'm going to combine my x's. X to the 6 times x to the 4th. You go ahead and you add your powers there. 6 plus 4 there is 10. And now I'm going to combine my y terms. Y to the 10 times y to the 6 there. I'm going to add my powers. And I get 16, so y to the 16. All right, and then our last one here. We're going to put, you got a power to a power here, so let's take everything to the second power. So 2/3 of a second, that's 2 to the second over 3 to the second. 3/4 of a second, that's 3 to the second over 4 to the second. I can look diagonally there and I can see that 3 to the second and 3 to the second there completely match, so I'm going to cross them out and make them 1s. 2 to the second there is 4. 4 to the second there is 16. I always look to see if I can reduce down any fractions there. I can reduce down 4/16. 4 goes into 4 there once. 4 goes into 16 there 4 times. So my simplified answer there is 1/4. Our learning targets there, I can factor trinomials where a is equal to 1. I can simplify expressions with positive exponents.